Okay.
Can you hear me? Today we will discuss the questions from model exam.
I think you would have done, and you need to, when I explain, you need to correct your paper, and finally you will have to calculate the marks for you, and then uh, write a explanation like you usually do. I will not give time for everything. You have to grasp the important points then and there when I explain and write it down somewhere. Put the question number and write one or two sentences. So calculations as explanation for your questions. Okay.
That should be done by you. You can't copy another one's explanation. Okay. So first question. A stone is thrown vertically upward. Which of the following quantities reverse in direction at the highest position? Okay. So I told you how to see the directions of each and every parameter. Displacement, when you look at it, displacement is decided by the position. Okay. So when something is thrown up, it will go like this. And momentarily, it will come to rest. It will come again in the opposite direction and will hit the ground. So when it comes to displacement, if you take the upper direction as plus, you'll have to take the level below the ground when you dig a hole or something as negative. That is the sign here. Sign convention, we call it sign convention, the method of putting plus and minus. If it is above the ground plus, it's always everywhere, it's plus above the ground. You will have to dig a hole to get a negative displacement. You can have in the middle also, or above this. Wherever you keep, you see the direction of the displacement won't change. It is always above the ground. When it comes to the velocity, it is the direction of the motion. The first half of the motion, it will be upwards. Second half of the motion, it will be downwards. So obviously, at the highest point, the velocity changes its direction. Okay. Then acceleration. Acceleration, guys, depends on the force, resultant force. So for this, when you use F is equal to ma, the only force is mg acting on it. If you neglect the air drag, and if you use F is equal to ma, F will be mg equal to ma. So always A is equal to g. So from this, you find out the acceleration. What I'm saying is, the direction of the acceleration is always in the direction of the resultant force. That's always downwards. Alright. So therefore, it doesn't change. Acceleration doesn't change the direction. So therefore, the correct answer is velocity A only. So in summary, displacement is position. Direction of displacement is about the position. Direction of velocity is about the direction of motion. Direction of acceleration is in the direction of the resultant force. Okay. Now question number 2. The ball is thrown horizontally with a velocity v from top of a tower height h. The ball hits the ground, making an angle theta with the horizontal as shown in the figure. Which values of v and h gives a higher value for theta? Okay. So this is a projectile motion. From a height, an object is thrown, right? From a height, an object is thrown. So the object here, and it is thrown like this. So when it comes to the final point where it hits the ground, it will have two components for the velocity. One is vertical component, The other one is horizontal component. Horizontal component will be equal to whatever the velocity is thrown. Okay. Horizontal velocity. So if you say it is ux, that will be still ux. But vertical acceleration is down. Downwards, it is g. For every 1 second, the velocity, vertical velocity will increase by 10. Okay, so that is decided by the time. The time is decided by the height. Or else, is there any shortcut that you have? If the height is h or the velocity, anybody? Don't know? You will tell if you had practiced enough.
V squared is directly proportional to S.
V squared is directly proportional to h. V is equal to what? What is the equation? Just tell me the equation.
V squared equals U squared plus 2AS.
So then I asked for the shortcut. Yeah, you know that, but 2gh, this is not difficult to remember, right? So if some of the things you might have to remember for your own benefit. So some of the teachers don't like shortcuts, but these come with the practice. Okay, so always be familiar with it. So height V is directly proportional to square root of h. So that is the theory. Now they are talking about the theta. So this is the resultant. Theta is the angle that this resultant velocity makes with the horizontal. Vertical velocity we will call it Vy. We'll call it Ux. So to find the direction, you go for tan theta, right? Tan theta equal to opposite side Vy over adjacent side Ux. So to have a maximum value for theta, you need to have bigger tan theta. You know when theta increases, tan theta increases. So you need to have a bigger tan theta. For that, you need to have a bigger ratio for Vy divided by Ux. This is decided by height. So height should be maximum. So Vy will be maximum. This should be smaller to get a bigger fraction. So V here it has been given as B. So therefore we will have to look for a lower value for B and higher value for height. That will give us higher vertical velocity and smaller horizontal velocity, increasing the theta. So among the answers given, the correct option is what? Come on, quick. Yeah, it is second one. No, second one. Question number 3. Acceleration time curve of the particle is shown below. Corresponding velocity time curve of the particle is best shown by. So you know, for velocity time graph, gradient is acceleration. So acceleration is the gradient. That thing you have to know and use. So acceleration increases. So the gradient of the velocity will increase, no? In positive acceleration increases. So positive gradient should increase. So it will be like this. And then gradient suddenly drops. So there should be a sudden drop in the angle. And it is constant. So after dropping, the acceleration is constant. Means there should be a reduction in the gradient. And then after that, it should be constant. Okay, so it should be straight line after a drop. So it will be like this. You need to show a drop. The last point here has a bigger angle. And then it suddenly becomes smaller. Okay, so that break should be shown. So the correct answer is the first one. Okay, correct answer is first one. Got it? For example, if the question is like this, acceleration time, how would the velocity time graph be?
Third answer.
It will be like this. Yeah, and then it should continue just like that. Third answer also a bit of a curve is there, even after that dot, but it should be a straight line after that. There should not be a break like this. It should not drop. The angle should not drop. Okay. When I erase, you need to like write the things. You have to use that time. Okay, when I erase, if you don't have any work, you can just look at me like this. And then when I start the next question only, sometimes you realize, okay, I have missed something. So use those times. You don't have any time to waste. Okay. Okay, a motor car moves with uniform acceleration alpha from rest, and then immediately continues with uniform retardation beta and comes to rest at time t. The maximum velocity of the car is. Okay, so it's a mathematical question. Okay, so initially it starts from acceleration alpha at rest, and then immediately continues with uniform retardation beta and comes to rest at time t. So usually your graph helps. So we don't know the magnitudes of acceleration and retardation, but we know the graph will be like this. We don't know which angle is bigger, we don't know. This angle or this angle, but uniform. So graph will be something like this. This angle can vary. Whatever the shape of the triangle it makes can vary. This is all we know. So maximum, this thing is the question. You know the total time taken is t. And you know the acceleration here. Here acceleration is alpha. Here retardation is alpha minus beta. Okay. Just to show that it is a retardation. Okay. Now how can you do that? How can you do that? Okay, so now what should you do is you have to use the equation separately for this and this, because the whole time given is two different types of motion. You can't use at once. Okay, you can't use any equation at once. So we will say this is t1 and this is t2 time. For acceleration is t1 time, for retardation is t2 time. Then you will make equation, and then you have to somehow remove t1 and t2. So what do you think you can do? How can you remove t1 and t2? Because you have to give the answer using given parameters. You can't insert something new. So how can you remove t1 and t2? You add them. Okay, when you add t1 and t2, it will become t. Okay, so for the first segment, we can write simply what? Acceleration is equal to v by t1. We can just write like this, no? Sorry, we can just write like this. Because you want to remove t1, you can make it a subject, so v over alpha is equation 1. And similarly, here it's deceleration, but still you can just write the formula beta is equal to v by t2. Okay, you don't need to put minus here. Okay, it's just for the value of retardation. Okay, just difference of velocity divided by time. it works. And then T2 is equal to what? V over beta. Okay. Now if you add these two, T1 plus T2 will be equal to T. Now you substitute V over alpha plus V over beta equal to T. Now you have to just make the V a subject. Okay. So here it's going to be my LCM alpha beta. V will be common factor beta plus alpha. Okay, grade 9 mathematics. V is equal to what? Alpha beta, alpha plus beta. Okay. So the correct answer is fourth one. So I can give you some seconds to write it down if you want. Okay. So always in physics, when you have these types of questions, you have to have some principle to solve. For example, here I used one principle. You have to find a way to remove new things. T1 and T2 are new. So I'm thinking about how can I remove it. So just by adding these two, I get T, which is given. So you have to make ideas like that. Okay. So there was another question. So what question? Okay, this is all given. So it's a velocity time graph. Initial uniform acceleration, then uniform velocity, then uniform deceleration. During the first part of the motion, it moves, during the acceleration, it moves S1 displacement. During uniform velocity S2, during deceleration S3. Total time taken is T. They asked for an equation. They asked, actually they gave values and asked for the maximum velocity. You can just try this with algebra. You can send me the answers. You can send me to dialog number. Okay. Find the equation for B. Okay. Okay. Now, question number 5. The graph shows variation of velocities with time of two particles A and B moved from same point, same time. Displacement of B relative to A is best shown by. Okay. So here the thing is, when they ask for displacement, relative displacement, after giving individual velocity time graphs, you have to use your relative velocity equation. And here they have what? Acceleration. So you have to find out relative acceleration also. For any relative vector, the common formula is this. For example, acceleration of A relative to B is acceleration of A relative to Earth minus acceleration of B relative to Earth. You can put E if you want. Okay. Now, what do you think about the accelerations there? Yeah. What do you think about the accelerations there? They're equal, no? Both are equal. So acceleration of A relative to B is 0. So this motion is not having an acceleration. This relative motion doesn't have acceleration. That's the first conclusion you come to. Second one, you have to look at the velocity, right? V A relative to B is equal to, VA minus VB. You agree with me? So what do you think? At each and every point, if you take any moment, you can see the velocity of A is greater than B by some amount. Always, always, always. So this has a value greater than 0, not 0. It is a constant value. You can see there. The gaps are not, varying, and you have also proved that relative acceleration is 0. So there is a velocity difference. There's a velocity for A relative to B, but no acceleration. Means it's a constant velocity. So for constant velocity, how does the displacement change? Constant velocity, displacement changes with constant gradient, right? Here the question is B relative to A. Okay. Because A is greater, B will be lagging behind, right? So therefore it should be negative displacement. Okay, negative displacement, but with a constant gradient. So the correct answer is third one. Okay. Do you have any doubts on fifth one? You write it down. Okay. Next question. The graph given in the figure shows the variation of velocity of a body of mass 1 kilogram with time t. Which of the following statements is faulty? Okay, so taking the mass 1 kilogram. So the amount of work done on the body up to 30 seconds is 0. So this question actually has, we have to study work energy to do this. This I mean, I have not discussed work and energy yet, but you have studied somewhere, right? Work and energy. Okay, work is a vector or scalar?
Scalar.
It's a scalar quantity, okay? It's not a vector quantity, it's a scalar quantity. But does the work have signs plus minus?
Yes.
Yes, it has signs. When the work is done in the direction, when the displacement happens in the direction of force, same as the force, by the force, then the work will be positive. If the direction is opposite, to the direction of the displacement is opposite to the direction of the force, the work done by the force will be negative. Okay. And if it has an angle, you will have to put a cos theta there. Just to get the component in the direction of displacement. You will get the component of force in the direction of displacement. So in this case, during the first 20 seconds, displacement is positive, the positive direction. Force is there because there is acceleration. Okay. So a work will be done. The second part, 20 to 30, there is displacement in the same direction as the first. It's also positive displacement. It's not going to the negative side. It's positive displacement, but the direction of the force has changed. So that work will be negative. Okay. That work will be negative. So here, if you calculate the work, okay, you can calculate the work by calculating the kinetic energy gain, kinetic energy loss. So those will be equal both. So it will be positive and negative. So the resultant work done after 30 will be 0. Okay, because it's scalar, you don't add. It's a scalar, but it has plus minuses. Okay, yeah. Second one, the mean acceleration of the body is 0. So mean acceleration is average acceleration. It is equal to the total velocity change, okay, divided by time. So here the total velocity change is 0, right? So that statement is correct. Third one, mean velocity of the body is 0. That's false. Mean velocity means average velocity. There is a total displacement. You can divide it by time, calculate it. So the faulty statement is third one. Fourth one, the mean value of the force acted on the body is 0. Yeah, that will be 0 because it has not produced any resultant velocity. Okay, so you have to use the average acceleration to calculate the mean force. Average acceleration is 0, so average force is also 0. Okay. Fifth one, mean value of the impulse acted on the body is 0. Yes. Okay. Impulse is force times time. F into time. So if F is 0, average impulse is also 0. The seventh one, the velocity time graph corresponding to the displacement time graph shown beside this. So in the seventh one, velocity time graph, displacement time graph looks like this. Guys, you don't worry about whether it touches the 0, it comes in minus or plus. Sign of the displacement is not our discussion. We have to look at the angle. Okay, so this angle is what? Tell me.
Obtuse angle.
Obtuse angle. So it's negative and it's increasing and becoming 180. So the gradient will decrease in negatives. Here it becomes 0 and then it will increase in positives because of the acute angle. Increasing. So the correct answer is in negative it decreases and hits the 0 and then in positive it increases. So it is the answer. Correct answer is fifth one. Okay. But even though generally this is the method that we do, but some people, so it's a bit, it's something that you should know because it came in 2013 all syllabus paper. Sometimes we say that obtuse angle has tan negative, right? Tan values negative. So we put it in the negative side. And acute angle has positive tan values, therefore we put it in the positive side. Even though we say like that, some people can change the convention. They will take obtuse angle as plus and acute angle as minus. If you ask whether it's correct, that is also correct. Okay, nobody can say direction of the velocity, this direction is positive and this direction is negative in a fixed fashion. It's decided by the observer. If they say one direction is positive, the other direction is negative. So therefore, it depends on the person who is deciding the directions. We generally take like this, and we will take the fifth answer as correct, but technically, fourth answer is also correct. In that question I told you, 2013, they gave a similar question like this, and they didn't give this graph, they gave the other graph, fourth one. So they had to choose that. They won't confuse in the final exam because there will be people who argue. Okay, so therefore they won't take risks. They will give completely different answers. But if they give both, you go with the general this method. Okay, but both are correct, actually correct. I think eighth one we have done a similar question. No, 2021 or something. Okay, question number 8. Okay, so ST graphs of the motorcycles P and Q traveling in a straight line are shown beside. Which of the following statements is wrong about the motion of P and Q? Okay, so you can see it's a displacement time graph. Okay, displacement time graph. P looks like this and Q looks like this. Okay, and at T1 time, they have same displacement. First statement, up to T is equal to T1, the distance traveled by both are equal. Displacements are equal. So therefore, distances should be equal. Okay. In graphs like this, okay, distance and displacement are usually same. One-way graph. Okay. If the graph turns like this, displacement graph is like this, then distance graph will be like this. Distance never decreases, no? But one-way graphs, increasing or decreasing trend, distance and displacement will be same. Because displacement is a vector, distance is a scalar. That's why it only takes increase. Okay. So that is correct. Second one, while P is moving with deceleration, Q is moving with acceleration. Yeah, true. Here, gradient is decreasing for P, gradient is increasing for Q. So, velocity increases for Q. So the statement is correct. Whereas P deceleration. Third one, the motion of up to T is equal to T1, the average velocities of both are equal. What do you say? Average velocities?
Equal.
Yes. Displacement divided by time, no? So total displacement divided by time. It can be acceleration, deceleration, whatever, but if both are same,
Hello? Hello, can you hear me? I got a call, sorry.
Yes, sir.
Okay. Now, what do we do? Yeah. So that is the third statement is correct. Fourth statement that t is equal to t1, velocity of q is more than that of p. You see, velocity of q is greater because the angle of q greater. Okay. And then after t1, they can meet each other once again. So after t1, if they follow the same path, trajectory, you call it a trajectory for the shape, they won't meet again. But that statement is not a good statement because it's two motorcycles. It depends on how they ride. Okay, so they can't say the trajectory, future trajectory unpredictable, right? So they can only give statements about what is there. They can't say what's going to happen. So because there are no other statements that are incorrect, we will select fifth one. Okay. Okay. Ninth one. A force F is applied on a moving object. On an object moving freely. At a particular moment, velocity of the object is v and the acceleration is a. The quantities that should be in the same direction. So, what are the quantities that should be in the same direction? Is there any rule that velocity and acceleration should be in the same direction? Is there any rule? No. Velocity and force? No, they are unrelated. Velocity is not related to displacement, acceleration. Always, acceleration is related to force. They can only be in the same direction. So therefore, the correct answer is V and A. Sorry, A and F. Second one. Okay. Question number 10. A ball is released. A ball is released from a point above the horizontal floor. Collide on the floor and bounces, rises again. Which of the following graph correctly shows the variation of the speed? Okay, time graph. So speed will not come in the negative. Okay, so fourth answer is not the correct answer. And it should be having a constant acceleration, right? Because it's under the gravity. So a curve is not possible. Third one is not possible. Fifth one is not possible. And speed will not be constant. So second one not possible. Correct answer is first one. After collision, because of the loss of energy, the velocity it returns with is smaller compared to the velocity it hit the ground with. Okay. It goes, hits, and returns back with a smaller velocity in the opposite direction. If it is a velocity time graph, you would draw like this. Like this. A smaller value than this you will give. But it's a speed, right? So it is the speed time graph they are asking for. So it will increase and then there will be drop. And you will draw like this because speed is not expressed in negative values. Okay. So first answer. 11th one. A golf ball hits the earth and the moon with the same force in the same direction. The shape of the path of the golf ball is so in the moon and earth. So what do you know about when it comes to projectile motion or a free fall? What are the key differences you see between the earth and the moon? Anybody?
Just tell me, it's general knowledge.
Gravitational acceleration change.
Huh?
Gravitational acceleration changes.
Can you? No, come again, come again.
What did you say? Moon and Earth. Gravitational acceleration changes, of course. What happens in moon?
When we throw with the same velocity, the ball we throw in the moon will go to a maximum height, like great height.
That is due to the G. I'm asking you, what is the exact difference between the G's? You guys don't tell what is the most important stuff. You know, but you don't tell. That's the problem with students. They are not to the point. You have to shoot to the point. One of you is telling gravitational acceleration varies between the moon and the earth. Yeah, I know that. What is the difference? Tell me.
Uh,
If the gravitational acceleration on Earth is g, on Moon,
G/6.
yeah, you know that. Or at least say the gravitational acceleration of the Moon is smaller. You don't have to know how many times. Just say smaller than Earth. That's what we want. So because of this, okay, when you calculate the maximum height using the equation upwards v squared equal to u squared plus 2as, the projectile motion, final velocity vertically is 0, initial velocity is v sine theta squared plus 2, a will be minus g into s is h maximum. So h maximum is equal to v squared sine squared theta divided by 2g. So when g is smaller, the height is bigger. Okay, so that's the thing. So vertical height, maximum vertical height will be greater for Moon compared to Earth. But there are many shapes. So now, compared to Earth, the vertical height is high. So in Moon, so it also takes more time to go to rest, right? Because the deceleration is smaller, and then it has to come back. Same amount of time is taken for going up and coming back. So it's a longer duration. So on Earth, the horizontal range will be smaller. On Moon, it will be longer because of the more time of motion. Horizontally use S is equal to ut. For u, what do you put? You put u cos theta or v cos theta. If initially means v cos theta into time. For time, what do you put? V sin theta divided by g, right? So you know it's v squared sin theta cos theta divided by g. So g is smaller, horizontal range will also be bigger. So that is also greater for Moon. Okay. So you can eliminate third answer, fourth answer, right? Then what about the shape? There are some symmetrical ones, there are some asymmetrical ones. Hmm? So what do you know about the atmosphere of moon? Is it thin or thick compared to Earth?
Thin.
It's thin. Okay. There is something called escape velocity. You will study when you study gravitational field. Escape velocity means the minimum velocity that a gas should have or an object should be thrown from Earth or any planet to get out of the gravitational field of the particular planet. Okay, particular mass, spherical mass. So that will be greater for Earth. So the molecules cannot escape the Earth. Earth has an atmosphere, therefore. But when it comes to Moon, Moon's gravitational field is very small. So therefore, you know, its gravitational field is, weaker. So therefore, it doesn't keep the molecules to it. So it's thin. So air drag is not there. But when it comes to Earth, air drag is there. Okay, what do you know about drag? You need to have some common knowledge about drag. Okay, drag is a force that is created by impulse, not the friction. So say an object is moving in this direction. Here there will be molecules, right? Air molecules are there. Now these molecules will rub its surface sidewards. When it goes like this, it will rub this surface and this surface. So in that case, it will produce a friction. In fluids, that friction is called, anybody?
Viscosity.
Very good. Viscosity. So that's a viscous force. That is there. That is also will be in this direction. For air, it is very negligible. But also, sorry, very negligible. In addition to that, these molecules will go and collide, right? So they will create an impulse that creates the air resistance or drag. That will also be there in this direction. FD. Opposite to the direction of velocity, okay? Air drag will always be opposite to the direction of velocity. Air drag is always against the direction of velocity, or you can call it relative velocity. All right. So they say that air drag is directly proportional to the velocity, relative velocity squared, directly proportional to the density of the medium, directly proportional to resultant area. And when you make it into equation, drag is equal to C A rho V squared. This C is coefficient of air drag. That is a constant for the shape of the molecule, shape of the particle, this object. Okay. Using this, it depends on the aerodynamics. Using this, you can make the shapes of the objects. If you compare a car or van to a CTB bus that has a flat face, the coefficient is definitely higher for that bus. Okay. But car, van, they have a kind of a streamlined shape. So the coefficient will be smaller. So when you manufacture a vehicle, you have to consider the coefficient of air drag. Okay, it's very stupid to create a vertical surface like for CTB buses. Okay, it consumes more fuel. Okay, so a little bit of curvature can change the aerodynamics greatly. So that will increase the fuel efficiency. All right. Yeah. They can make a say question. They can give you the values for C. They will ask you to calculate the power and they will ask you how much you can save for this many kilometers. Like that. Okay, mechanics. So whatever, this is the thing about air drag. So when it comes to density, that is greater for Earth. Okay, other factors can be same, but density is greater for Earth. It's almost zero in Moon. So therefore, significantly, Earth will give a drag force. So due to the drag force, the horizontal velocity now will undergo what? Deceleration. Horizontally, usually you don't have a force. Horizontally, you don't have a force now. But air drag will give a force like this. So now horizontal velocity is going to decrease. So instead of going like this, it will have a shorter pathway because the velocity is decreasing. So it's not symmetrical. This side is smaller than this side. So therefore, correct answer is fifth one. Fifth one. Oh, yeah, fifth one. Fifth one. Okay. Any questions?
Nihla, you have asked me a question. I don't know that is relevant to which question. You asked with a 90-degree or something. I don't remember for which question you asked. Okay, question number 2.
For that to be 90-degree,
For the equation, H is equals to
why 90-degree? It's impossible,
the
right?
equation H is equals to square root GH.
You are uh, trying to mention the extreme situation where it's almost 90.
No, sir, like sir told now
Yeah.
H is equals to square root 2GH.
Yeah.
Like for the equation for H maximum, it is H max equals to V squared sin squared theta over 2G, right? So when theta is 90, then we can get H is equals to square root 2GH, right? Sorry, V is equals to square root 2GH.
Hello, give me 2-3 minutes, okay? Okay. Now, when there is air drag, when you throw with the velocity, when they come, the velocity will be smaller, okay, in a normal vertical motion because of the loss of energy. And then, what do you think about the time taken for moving upwards and coming downwards? Just try to work it out, all right? So, usually, when there is no air drag, when they go up and then come down for both motion, it takes same amount of time. But when air drag is there, it takes different amounts of time. Just try to kind of work it out which time is greater, going up or coming down. That was the statement in old question. And about your 90-degree, yeah, actually, when you put 90, you get the equation. That is for the direct throw and fall. But for projectile, you can use, but for the vertical component of the projectile motion. Okay.
Okay, sir.
Okay. Okay, now the following two particles A and B are thrown simultaneously from certain position in horizontal flow. Okay, so at the moment of the throwing, A has a velocity u vertically and B has a velocities u and V horizontally and vertically respectively. The moving part of A relative to moving path of B relative to A in the motion before reaching the flow. So when they reach the flow, one will travel in vertical motion. A. So when it reaches the flow, it will come like this. It's same U. But when this thing reaches the ground, B, it will have a vertical velocity U and horizontal velocity V. Relatively, because these two have U vertically downwards, that doesn't bring a relative motion. What does this have additionally V? So that is the motion of B relative to A. So it will be horizontal. Relative motion will be just horizontal because they both have U. When you both of you are traveling in the same velocity, you don't have relative motion. So these two components cancel out when it comes to relative. This will be remaining. So the answer is fourth one. Okay. If you want to write equation, you can write, but that's waste of time. 13. The figure shows the moment when particle P is thrown with a velocity v vertically upwards from the flow at time t is equal to 0. And another particle Q is slowly released from height h straight above the position of the first particle. In the following motion, both particles meet each other. The graph is shows the variation of velocity v with time for both. Now, triangles ABC, CDE, and ADF are area A1, A2, A3 respectively. The correct relation of H is. So, first you need to understand what's happening. Okay. You are throwing P vertically upwards. Yeah, that is there. And this downwards with 0 velocity. Okay.
that is shown by the graph Q. And they are meeting at some point. The total distance between them is h. Now, where do you think does the collision occur? That's my question. Now tell me at what moment of the particle P, this particle, does the collision occur according to what you see in the graph? You have to pick it up.
Particle P will go up and come down.
Yes, it will reach the highest position, 0 velocity, and then it will start to move in the opposite direction. Then only it meets. So when they meet, they are moving in the same direction. Is that correct?
Yes.
Yes. So when they meet, actually P has gone and come down, and then only this is coming and meeting. Okay. So the path of P is actually this. Path of Q is this. Okay. Path of Q is this. This is H. So this thing you have to understand. Okay. Now ABC, look at it, ABC, which is A1. ABC for P is the distance from here to the highest point here. This is A1. CDE is, look at it, look at the graph. It's in the negative side, right? Means after reaching rest, it comes down a bit. So that distance is CDE. CD is given by the letter A2. What is ADF? ADF, distance traveled by Q, no? So this A3. Okay, do you understand? You have to mark the distances. Now, how will you relate them? How will you relate? In relation to H, yeah, how can you write? H will be equal to A1 plus A3, but there is an overlap, no? So here subtract the overlap, minus 8. Okay, this A2 is added to this and this. You can use it only once. So what you do is you subtract it so that you are using it only once. Okay, do you agree with it? The correct answer is third one. Okay. Okay, now next question is easy, okay? Easy. 14th one, how many times the particle comes to rest? So in a ST graph, rest means when the gradient is 0. So when the graph is like this, okay? These flat points are rest. 0 gradient points. Okay, so you have to just calculate it. 1, 2, 3, 4, 5, 6. Totally 6 are there. Okay, 14. One correct answer is 4. This came to our Morato paper. Okay. I still remember I just did 1, 2, 3, 4, 5, 6. That's the way to do. Okay. It could have been difficult for some. Okay. Because not all of the students go with preparedness. They don't come to some conclusion so that they can use those conclusions in the exam straight away. You have finished the thinking when you study. You have to go with the final sense that you have gained from all the hard work, thinking, processing, okay, making mistakes and learning from it. All those things will come to a point where you just apply in the exam. So until that, you have to practice. Not everybody can do that. You have to allocate time and you have to try to do it the way that you want to do it the exam. First time it will take time and then you have to improve. Okay. So that you do within a short period. You have to try it deliberately, try to do within a short time. If you don't try it, you will even the 6th time, 7th time, 10th time, you will take the same amount of time. So always think, how can I do it easily? Is there any other way? $15. Particles XYZ are thrown from a point on the ground with the given horizontal vertical velocities PQ are the possible paths of the particles between the period just before and after the particle reaches the maximum point. Just before and after the particle reaches the maximum point. Okay. Okay. So it is just before and after, right? Hello. Sorry, I'm sorry. I got a call. Okay, bye. Have a chat. All right. Now, if the path of X between the period just before and after the particle reaches the maximum point is P. For X it is P, okay, they are saying. What is the particle of Y and what is the path of Y and Z? So we will show X has a vertical velocity U and horizontal velocity V. Okay. Y has a vertical velocity 2U and horizontal velocity V. Z has a vertical velocity U, horizontal velocity 2V. So P is a path like this. Okay. So P is the pathway for X. Now tell me, what are the factors that affect the shape of the path? Two factors, tell me.
Height and velocity.
Huh?
Height
What?
and velocity.
Rate and velocity.
Height.
Great, huh? What is the first word?
Height, sir.
Height. You are saying height and the velocity. Haha. So the path just before and after reaching the, the path is decided by the vertical and horizontal velocities. Right? There's a simple answer. So that will decide the angle. That angle varies in PQR. When the vertical is greater, angle will be greater. When horizontal is greater, angle will be smaller. Now, if you take it as like time t is equal to t, just before and after, no? So just before means 1 second before, let's say t minus 1 time, 1 second before, and after t plus 1. What do you think is the vertical velocity? 1 second before reaching the highest point?
10 meters.
Yes, it's 10. Whatever you throw with the initial velocity, it will be 10 1 second before. If you want to take 2 seconds for all three, it will be 20. So it doesn't depend on the initial vertical velocity that you have to understand. All of them, the vertical velocity that you consider in the upper portion will be same. Okay. Just 1 second before and after, if you imagine, it's going to be 10, right? For all three. Whatever you throw it with initially. So therefore it's 10, 10. Okay. So the only factor that is going to change between these three is horizontal velocity. That is, initial velocity remains throughout the motion. So for P, if this is the path, what do you think for Q?
The
Both
same
have
path.
same horizontal velocity. So therefore same
Path.
path. This doesn't matter. Okay. Here, this is greater. So therefore, angle will be dragged toward this side. So it will be like in diagram Q. Okay. So for Y, it will be P, same as X. This one, this is different. No? So angle will be smaller. So that will be Q. Okay. Alrighty. Now your correct answer will be there, mark it. Okay. P and Q. So therefore the correct answer is fifth one. Sixteenth question came in 2017. It's a tricky question. Okay. It's a tricky question. It is called A. This is B. There is a ball Okay. The 16th question, read. A small sphere is released from rest from point A in a firmly fixed frictionless track, which is a quarter of the circular path of center O. Quarter of circular path. Quad circle. Okay. So center is given here O. And they have shown this as R. R is the radius of this arc. Okay. Path of center O. And radius R is shown in the figure. The sphere leaves the track horizontally. Yeah, if it is exactly quarter circle, then it will be leaving horizontally. And then after that, what is the motion? It leaves horizontally from here.
Projectile.
Yeah, it's a projectile. Okay. It will hit the ground. So they say it hits the ground at a certain point C. C is not shown. They won't show because some students will measure the lengths. Okay. So that won't work. You have to mathematically think. They don't draw the diagrams according to scales, even if they show the C. Now, the distances traveled by, if the times taken and distances traveled by the sphere from A to B and B to C are TAB, TBC, and SAB, SBC respectively. So distances, okay, distances means you measure the total length. And time taken. Which of the following is true? Okay. Now, can I see your answers in the chat, please, all of you? So one of you is thinking it is first answer, fifth answer. Okay, now we will compare the times. Students, this is projectile, no? And this also, they say R. Now, when you try to do calculations to find the time for this fall, it's totally possible because you know the vertical height, you know the acceleration, initial velocity is 0, so you can use S is equal to half AT squared from B to C. S is R vertically, half A will be G, T, BC squared. So TBC will be equal to 2R over G squared. I'm just deriving the equation, okay? So it's a free fall through a height R. Now, what do you think is happening during this motion? Is there any way to find the time taken for the motion? Is there any equation you can use? This motion doesn't have a constant velocity. Constant acceleration. Here, it will have acceleration G. At the very beginning, it will be like a free fall. Here, at a random position, the acceleration will be G, whatever the theta it makes, G sin theta. Okay. Here, vertically, there is no component of velocity. It's moving horizontally. Horizontally, there is no force. So here actually acceleration is 0. So do you agree that throughout the motion, the acceleration decreases to 0 from g? Do you understand that part?
Yes.
Yes. So now you can use some, approximation, because here they ask you just to compare. They are not asking you to derive an equation for the time taken. Comparison. So for comparison purpose, from A to B, I'm going to use some equations approximately. Okay, A to B. For the average motion. Okay, for the average motion. What is the total displacement there? Huh? Total distance traveled, just tell me. You know, right? Quarter circle, 2 pi r divided by 2. So it will be pi r by 2 pi r divided by 4 pi r by 2. That's the distance traveled from here to here. And you can use s is equal to half at square because initially it's 0 now, velocity. So you can use this. S is equal to half at square for the average motion. You don't look at the direction for average motion, just to have a calculation. So S is pi r by 2. Okay. Half. A is, you don't know, but it's not G definitely, because it varies from G to 0. So the average acceleration, if you talk about it, it should be less than G. Do you agree with that?
Yes.
Yeah, because it's ranging from G to 0. So it's between 0 and G, not greater than G, equal to G, less than G. So it is a average, I would say, but less than G into time, AB. Now students, look at it. This equation, you need to compare. Here it is R. Here it is pi R by 2. Is this value greater than R? Which is greater? Pi is 3.14. When you divide it by 2, it will be like 1.5. So it's like 1.5 R. So it's greater, no? Acceleration A average is smaller than G. Now, when it comes and divides, when this comes and divides, think about it. R is a smaller value, G is a bigger value. This is a bigger value, this is a smaller value. So definitely the time TAB will be what? Greater than TBC. Because this is greater than R, this is smaller than G. So the dividing number is smaller. I mean, the denominator is smaller, numerator is bigger. So TAB should be greater than TBC. Do you understand? Huh? Hello?
Yes, sir.
Makes sense. Yeah, there is no other possible comparison that we can do. This is the best possible way that I could find out. So anyway, it is greater for AB. Okay. Now we need to compare the distances. When it comes to, so write it down if you want. Okay. Now comparing the distances, AB distances you already know. What is it? A to B, the distance is pi r by 2, right? Pi r by 2. B to C, you have to measure the distance. You have to measure the length of this path. It's a parabola. For a projectile motion, the shape is a parabolic shape. So this is parabola. You need to measure the length. I don't know any equation to measure the length of a parabola. Do you know? And you don't need to actually. You have to just compare, right? Now, can you find out this? Anybody who found out the range, horizontal range? Huh? Yeah, you have to use the equations. First, you need to find out the time. Time is already there for you. Horizontally, you have to use S is equal to UT. Horizontally, what is the velocity here? If you use law of conservation of energy, V is equal to square root 2gr. If the vertical height is r, students, come on. What is the velocity? 2gr. Do you agree with me?
Yes.
Yes, here 2gr. And time is what? 2r by g. Square. G chopped off. If you calculate, it will be 2r. Okay, so it will be 2r. Now, this is a quarter circle, right? Like this. This will be r. This will be r. This is the distance SAB. This one. I'm just putting it the other way, just to compare. But think about this length. This is r. This is 2r. So it's somewhere here, and this path is something like this. That is SBC. Okay. So I hope you can clearly see that because it's twice the r, this pathway will be definitely longer than AB. Right? BC will be greater than AB. So with your eyes, you can just approximately say that. Okay. So therefore the correct answer is what? First one. Right? First one. Oh, I'm tired. Question number 17. A particle is flung from a point A in the horizontal plane that passes through two rings located in the same horizontal level. Okay, they are located in the same horizontal level. It took 1 second for the particle to go from A to X and X to Y each. They ask the heights were the rings positioned from the ground. They are in the same level. Okay. So A to X, it is 1 second. X to Y, it is 1 second. Okay. Then you know from Y to final point also, it should be 1 second because the projectile is symmetrical. if this is 1 second, this will also be 1 second. The question is, what's the vertical height? Who? How can you find out? Okay, to divide it, this will take 0.5 no? seconds. This will take 0.5 seconds. So what will be the velocity here? Huh?
5 meters
The
per minute.
velocity. Highest point is 0 vertically. After 0.5 seconds, it will be 5, right? And it moves for 1 second under gravity. So you can find the vertical height. This is equal to ut plus half a t square. U is 5, t is another 1 more second, plus half a is 10, t square is 1 square. So 10 meter. Correct answer is fourth one. Simple maths questions. Okay. Do you want me to explain question number 18? A tea strainer was slowly dropped by a man. From the ground. The given figure shows vector representation of the instantaneous velocity v and acceleration a of the strainer. Now, at a certain instant during its motion, if the air resistance is considered, I mean, T strain means it has a parachute-like structure, right? You know, the cloth one, the cloth filter made up of cloth, significant air resistance will be there. So it's the vector they have given. They're asking you after it has fallen for some time, what will be the vector? Okay, so now air drag is there. So that will actually reduce the acceleration due to the drag force. Okay, so acceleration will be smaller, but velocity will only increase. Reducing acceleration will cause reduction of the rate of increase of velocity. But velocity will increase only, not decrease. So therefore, velocity should increase, acceleration should decrease. Correct answer is fourth one. Question number 19. Particle A is thrown vertically downwards. Particle A is thrown vertically downwards. While particle B is thrown horizontally from same horizontal level above the ground with same speed. Means they have different directions but same amount of speed. So we'll take it as x and this as also x. But this is vertical velocity, this is horizontal velocity. Neglecting the air resistance, which of the following statements is correct? So which will reach the ground first and which will have greater velocity is the question. So which do you think will reach the ground first?
A.
A. You think A will reach the ground first? Why is that?
Because it has a vertical velocity.
Yeah, they both pass the same vertical height, but because it has a vertical velocity, yes, it will take smaller time. So A reaches first. Okay, A reaches first. What about the final velocities? Final speeds. When this thing hits, it will have this x velocity and it will have a y vertical component due to the acceleration during that time, right? When it reaches the ground, it will have this already existing vertical velocity plus the rest of the acceleration one. So how can you compare the increase of velocity here and the increase of velocity here? Which will have a greater final velocity, this or this, same height. So vertically using v squared equal to u squared plus 2s. For this one, there will be a u squared. 2as. A will be the g, s will be the vertical height. As part is staying for this and this, right? You got it. Additionally, this will have u squares in the equation when you calculate. So final vertical velocity is greater for this. Now here, y is smaller than this vertical velocity, let's call it z. And here it is not addition, it's Pythagoras. Okay. So this is a smaller resultant velocity. So the correct answer is particle A will hit the ground first. B will hit later with a smaller speed, okay? Not bigger speed. Okay. I think no answers are there. Okay. But anyway, it's a model question. Okay, we don't need to worry about it. Okay. Do you have any questions now?
So in that seventh question, you said that 4 and 5 will come as answer, right?
Huh? Seventh question, which answer?
Like
Actually,
4 or 5
iPad
can
went
come.
off. iPad went off. Can you read the seventh question? Tell me what's the exact doubt.
Like the velocity velocity time graph corresponding to the displacement time graph. Like it is like a curve.
Downwards curve.
Yeah, like
Yes.
but in the fourth answer, the area is not equal in the positive side and negative side.
That of course is there, no?
So we cannot take that fourth one, right?
Yeah. We can't take. Then we can't take. Okay. It's returning to the same point. So we have to take equal area on. Okay. Okay. We'll finish. Thank you.